while Mr. Mead is setting up, I want to introduce myself. Other council has already had an opportunity to. My name is Dominic Williams. I'm an attorney for TVA. This issue is pretty near and dear to my heart. I am born and raised here in Shelby County. And I just wanted to thank the board for your time. I know you all have things to do, that this is a volunteer role for you. And I just want to thank you all for being here, sitting through this all day, and putting your personal and your business responsibilities on hold. I really do appreciate it. At this time, TVA calls Allison Crawl, please.
Crawl, will you raise your right hand, please? Do you solemnly swear to tell the truth, the whole truth, and nothing but the truth, so help you God? Your witness.
Thank you. Please state your name for the record.
Allison Crawl.
Would you please walk the board through your educational background, please?
Sure. So I graduated from the University of Kansas in May of 2008 with a bachelor's degree in mechanical engineering. I'm also a licensed professional engineer in Kansas, Arkansas, Kentucky, and Tennessee.
And what is your specialty?
I specialize in the mechanical design for systems in a natural gas combined cycle power plant.
And who are you currently employed in what capacity?
I'm employed by Kiewit Power, and I am a senior mechanical design engineer.
Thank you. How many facilities have you been involved in designing of?
A total of 4 facilities, all natural gas combined cycle in Canada, Idaho, Kentucky, and Tennessee.
And as it relates to the Allen facility, the reason why we're here today, what duties did you have in relation to that facility?
So I am the lead mechanical engineer, which means I'm ultimately responsible for the mechanical design of the plant.
Did you see all the drawing?
Yes, it was myself and I had a co-lead.
The section under which you work on?
Yep.
Okay.
If you would, please walk us through briefly what the Allen facility is.
So it's a 2-on-1 combined cycle facility. Tibbs mentioned before that, so we have the combustion turbine and hoisting trains of boilers. The boil the steam, send it to steam turbine. And then we also use a closed wet cooling system.
And as it relates to the cooling system, could you walk the board through how that process works?
Yes, so the cooling system is comprised of a steam surface condenser, plated frame heat exchanger, which would be a part of this box right here, a cooling tower, and pumps to recirculate the water. So the condenser uses cooling water to condense the steam that's exhausted from the steam turbine, and we use that condensate to reintroduce back into the steam cycle. The plate frame heat exchanger picks up heat throughout equipment in the plant, and the cooling water is used to basically take that heat so you can keep your bearings cool and equipment functioning. So once the cooling water leaves those 2 pieces of equipment, it's hot and it's of no good use. So we have to send it back to the cooling tower, dissipate the heat to the atmosphere so that we can reuse it.
And why is the cooling system essential in layman's terms?
In short, if we don't have a cooling tower and cooling water, we're not making electricity.
It basically doesn't work then, is that what you're saying?
You can't operate the plant.
Would you please describe some of the advanced technology? I know you mentioned a couple of things so far, but would you describe some of the advanced technologies that's used to promote efficiency?
So all of the wastewater that is accumulated in the plant is sent to the cooling tower so it can be reused in the system. Dan Tibbs also mentioned that we are cycling up our cooling tower. So cycles of concentration. Essentially, when you are putting water into the cooling tower, some of it's going to evaporate off, and that's going to concentrate your dissolved minerals in the water. So higher concentration just means we're keeping that dissolved minerals higher. But operating at higher cycles basically reduces this breakdown number, what we have to reject onto the site.
And why is, or actually, what's the most efficient medium for cooling.
Water.
And why is that?
It has better heat transfer properties and ultimately makes the plant more efficient.
You've heard a lot of testimony today, a lot of reading today about how efficient the process or the plant is. Would you consider this plant to be efficient?
Yes.
In relation to plants regionally, would you consider it to be less or more efficient?
More efficient. So the type of equipment that we're utilizing in this system is on par for various plants in the region. But again, the way we're cycling up the tower to minimize that blowdown is how we are making this system more advanced.
Thank you. What ways does the Allen cooling system help prevent excess water loss and promote efficiency? You heard some talk from Sierra Club about this efficiency and also about water loss and how there's no technology actually being used to help with water loss. What technology would you say is actually being employed here?
So the cooling tower allows us to reuse 300,000 GPM. We do have to make up some of it, but it does allow us to reuse some of the water. And then we also have online sampling systems that allow us to monitor the water chemistry and therefore help us regulate the blowdown flow rate.
So, for instance, when the Sierra Club says that there is nothing that actually, no cooling towers actually used, would you agree with that statement? If you would, I'll let the court, may I speak?
Go ahead.
That comes from their application. In their application, they state that section 11, this is on page 3, about the limited water use. This also was in the opening of Sierra Club's council, and also statements made in building questions in cross-examination that additional cooling systems, there's no cooling towers, and they failed to use a document that there was a condensed, recapture, and reuse of water. I'm simply allowing the person to explain and allowing the witness to explain that that is not true based upon her designs and the fact that the plant actually has cooling towers.
You may continue.
Thank you.
Overruled.
And simply, I will draw the question and just ask you, are there cooling towers used here?
Yes.
And are there efforts to recapture, condense, and reuse?
I am not aware of that technology. There has been some papers written on trying to utilize some of that technology, but I have not seen it in practical use.
Thank you. Is this cooling system a once-through system?
No.
What's a once-through system in comparison to the system that's put through, that is at the Allen facility?
So a once-through system involves an intake structure on a large body of water, like a river or a lake, and that water is pumped through the condenser and heat exchanger. The difference being that when it comes out of that equipment and it's hot, it is simply just discharged back to that body of water. You do not reuse any of it.
When the Allen facility is producing water, how much cooling water is continuously recirculated through the cooling water system?
About 300,000 gallons per minute.
And what's the average makeup flow loss during the cooling system process?
So total makeup flow is 2,400 GPM on average. We lose 2,200 to evaporation, and blowdown average is about 200 GPM.
So is it correct to state that your water loss is really a function of two processes, blowdown loss, blowdown, and then also evaporative loss?
Yes, that's correct.
Is evaporative loss a static and a function of physics? Is it something you could change?
It is constant.
And could you explain blowdown loss and evaporative loss in relation to this chart?
Yes, so this graph shows your blowdown flow rate versus the cycle of concentration. So the number of times you're going to cycle up those minerals. The red line across, this represents the loss to evaporation, which is the 2,200 GPM. And what we're showing here is this is for the Allen combined cycle facility. So it's kind of hard to see, but where we're designed to operate is in the 10 to 11 cycle range. So that corresponds to about 200 GPM of blowdown. Now, typical combined cycle plants operate in the 4 to 6 cycle range. So you can see that that blowdown rate almost triples to 600 GPM. So that's where we really are trying to utilize the cooling tower design to minimize the blowdown flow rate.
And what water is being used or depicted in this slide?
This is based on the Memphis Sand Aquifer.
And if you were to use less efficient water, say potable water, reclaimed water, would the blowdown rate be as good or would it be worse?
The blowdown rate would be higher. You would, with a lower quality of water, you would not be able to achieve these upper cycles of the cooling tower.
You said potable water is lower quality water?
Potable, you would be somewhere in the similar range, but the alluvium and the reclaimed water, you would be down in the lower range.
And will TVA have another witness who's going to discuss a little bit more about quality of water?
Yes.
What's the consequences, does less efficient water source create greater waste and environmental impact?
Yes. So less efficient water, higher blowdown rate, higher makeup rate required. Basically more wastewater we have to send to Maxim.
So another way to say that, would it be that the better the water source quality, the lower the blowdown rate?
Yes.
Would the lower the blowdown rate be equivalent to less water or wastewater produced?
Correct.
And the less wastewater produced would mean more economically friendly process.
Yes.
Two more questions. What would be the impact to the Allen facility and the cooling water system if it was supplied with insufficient amounts of water?
It wouldn't operate.
And what would be the impact to the Allen facility if it was supplied with insufficient water quality?
You wouldn't be able to operate at the range it was designed to.
Given your expertise and also given your involvement with the design of the Allen facility, is there anything else you would like to tell the board about?
So Dan Tibbs mentioned the water study that Keyword performed for TVA. So we spent 6 months really evaluating this system. We looked at multiple water sources, multiple equipment configurations, reached out to vendors to have them help us specify equipment to treat the gray water. 13 of the 15 configurations utilized gray water, and those solutions really just weren't viable. A couple of equipment vendors stated that the type of equipment needed to treat the gray water, they would see at a wastewater treatment facility, not a power plant. Typical power plant operators don't have that kind of background to be able to operate that equipment.
Thank you so much for your time.
I'm sorry. Go ahead, Ms. May.
Just one follow-up question. Actually, TVA council raised a question earlier, so I'm just going to follow up with you. There's concern expressed about the number of wells TVA plans to install in the Davis well field area. So my question to you is, what during the scenarios that were evaluated, was there a scenario evaluated that had a hybrid of using MLG&W potable water and fewer wells?
No, we did not look at that. We basically had 2 separate treatment configurations.
Was that a possibility as a scenario, or is the piping so distinct you had to go one path or the other?
No, and we could do a hybrid system.
Thank you.
I want to follow up on that because her question is exactly what I was going to ask. Like you said that the whole purpose was to have a redundant system so you can make sure you're always available, have gas available or electricity available. And what's your backup to your well system?
I'm not trying to.
Mr. Carter.
I believe Mr. Johnson has been recused himself from the hearing.
Yeah, but I'm
I
not,
would believe that would. also.
It's good information to have.
We'll let him continue. But Mr. Carter does make a point that if you're going to be recused from deliberations, you probably shouldn't be asking questions.
Okay.
If I may.
Mr. Meade?
Yes. I think that I've overheard that maybe during the break after Mr. Tibbs stood down, there was a conversation about whether or not questions could be asked.
Yeah.
I think some of these questions might better be directed to him. We would have no problem.
I'm going to recall Mr.
We
Tibbs.
would recall him to allow the.
Before that, so you designed the water production facility, water production site?
Yes.
Okay. How are you treating the water as it comes out, the raw water? What are you doing to modify or alter?
From the wells?
Yes.
Nothing. We're sending it to the cooling tower, and there's, I'll call it standard cooling tower chemical treatment. that we
Exactly.
typically do, so we modify the flow rates
Are you doing any iron removal?
with the corrosion removal.
But you're not removing it before it goes into your process?
Nope. So there's no mechanical equipment upstream of putting it in.
So you're not oxidizing the iron and then removing it by filtration?
Correct. I'm not doing that.
You're basically, gallons that you pump out of the aquifer are going into the makeup work.
Correct.
So basically, well, it's gone now. Back up. Yeah, that's my thing. You're dumping it into that blue circle between the cooling towers and the water uses.
Yes, it's coming from the well straight to the.
Straight into that. You're not doing, there's no backwash water or wastewater taken from the aquifer and not utilized in process.
Correct, it is all.
Thank you.
back to the system.
If I may, we'll have another witness right after this that can discuss why this is possible aversion to other types of actions. Senator Lynch.
Mr. Brewer?
Good afternoon. Where were the other 4 plants that you designed the cooling system for?
There's one in Ontario, Canada, one outside of Boise, Idaho, Paradise, Kentucky, and then the Allen plant here in Memphis.
Over what period were those others constructed?
2008 to present. So the Canadian job was the first project that I worked on.
How many of them use wastewater or gray water?
None of them.
None of them do. There was a videotape played earlier of the president of Memphis Gas and Water, Jerry Collins. He stated in that video that the quality of water supplied by MLG&W would be greater than that which came straight out of the well and would require less treatment. Did you hear that testimony?
I did.
And based on your testimony, as I understood it, and I hope I did understand it, that the lower the quality of the water, the lower the functionality of it. Is that a fair statement?
Yes.
Wouldn't it be true then that if the water from MLG&W was of a higher grade, that the system would operate even more efficiently?
So Charlie Fritz was really involved in the water study. He's going to follow me, but there are some constituents that we don't agree are better in the MLGW water than what's in the well water. So he can go into more detail of whether we think the MLGW water is of better quality than the well water.
When did you become involved in the Allen project?
So So I was involved in the estimating phase when we first received the proposal from TVA. And then once Kiewit was awarded the job, I rolled onto the production team as the mechanical engineer.
When would that have been, 1 year?
It would have been early of 2015, and then we were awarded the job in June of 2015. So basically, January to June, I was working on the estimate, and then I rolled over into the production design.
But the plan was to use gray water for some period of that time, is that correct?
Yes, it was.
And that was up until there was an analysis done of the gray water that would have been the source? Did I understand that correctly?
Yes, that's
Would it be your statement based on your experience that gray water should never be used for a cooling system?
Oh, no. I mean, it is definitely a source to be looked at for makeup, but when we started looking at the quality of what was coming out of Maxim, it was a very difficult water to treat.
Would you have any estimate of the cost of treating that water?
Looking at our water study, it could be anywhere from, I want to say 8 to 23 million in equipment cost. So capital cost, and that includes installation and startup, with a yearly chemical cost of around 6 to 8 million. And as I understand it, that's the entire plant operating budget for the year. And that would just be using chemicals for just the gray water treatment system.
Is it ammonia?
The ammonia is pretty difficult to
Yeah,
do.
ammonia's tough.
Yep. And
It's
there-
tough to get rid of, and it's tough on everything around.
And there are very high concentrations of ammonia in this water, as well as phosphates that make it very difficult.
To get the ammonia out.
Yeah, because you basically have to have a denitrification of the water for bulbs, essentially.
I was confused a bit by your testimony about the reuse of the water. I had understood from the prior witness, Mr. Tibbs, I believe, that there could only be, the water could only be cycled about 10 times and then would go to the Maxim water site. Did I understand that correctly?
So the way we regulate the cycles is through that flow down flow rate. So the only water that we cite is the 200 GPM going to Maxim and the 2200 that's lost to evaporation. The rest of that 300,000 GPM is recirculated throughout the system. So in order to maintain the 10 to 11, we're only creating 200 GPM of wastewater.
And that's per what day?
I'm sorry.
What is that per what? A day, week, or what?
Per minute. So,
Per minute?
So the 300,000 GPM gallons per minute that we're recirculating, only 200 of that needs to be sent to Maxim to maintain the 10 to 11 cycles as designed.
But you do agree with the estimate that there would be about 3.5 million gallons lost per day in the process?
Correct.
I have no further questions.
Redirect.
No redirect, Your Honor.
Next witness.
For the record, TVA calls Charles Fitz.
telling the truth, tell the truth, the whole truth, and nothing but the truth, so help you God.
I do.
Thank you, Your Honor. Good afternoon. Please state your name for the record.
My name is Charles Fritz.
Would you spell your last name for the reporter?
It's Fritz.
Thank you. Could you please provide the board with a brief description of your background, education, and work? Primarily education.
Yes, I have a Bachelor's of Science degree in chemical engineering from the University of Missouri in Columbia in 1965. I have registered professional engineer in the state of Missouri. Spent about 50 years in the industrial water and wastewater treatment business,
Thank you.
mostly in power plant applications.
Excuse me, thank you. Could you please open your black binder and look at tabs 9 and 10? Do you recognize these documents?
Yes, I do.
What are these documents?
There are two documents. One is the water treatment study done by Hewitt Engineering and Design, October 2015. The second is an addendum to that study issued in October 2016.
Thank you. This time, Your Honor, we move to have 9 and 10 entered to the record.
Any objection? What exhibit was that? 9 and 10.
Thank you. Were you involved in the conducting of the Allen Water System study?
Yes, I was.
The water study contains 2 sections, right? You mentioned earlier there's a 2015 study and then an addendum to that study in 2016, correct?
That is correct.
The study looked at 2 primary functions and impacts, financial and reliability, correct?
Correct.
And why not just look at finance? Why look at reliability as well?
Well, the economic analysis that was performed is necessary to establish the most cost-effective systems. We did that with nearly all studies that we do. And as mentioned earlier by the previous witness, we did look at numerous scenarios for treatment scenarios, most of which apply to the wastewater water source. We also look at reliability. That's very important, particularly in a power plant, as Mr. Tibbs has testified. We have to require a great deal of reliability. And there's a number of risks associated. Every scenario we study has a different set of risks associated with them. Some of these risks are related to the water source. A water source that is variable in quality requires a much more diligent treatment approach to try to follow these changes and avoid upsets. There are complexity issues with the equipment. They're very complex, multi-step pretreatment systems that might be necessary, involve a lot of operator effort, and therefore may be issues regarding reliability. And then finally, I would say that there are risks associated that are technical risks. That has to do with the treatment systems that we study. Some of these have a better track record than others. It was mentioned that some of the systems were better suited for operation at a sewage treatment facility because they're biological in nature. Typically, power plants try to avoid that type of treatment system and rather go with the physical chemical treatment approaches.
Thank you. What 3 water sources were reviewed during the 2015 study?
We looked at the reclaimed water from the Maxim facility. That was the initial water that was anticipated. We also looked at then the potable water from the city, and we looked at water from wells in the Memphis Sand Aquifer.
And you call it reclaimed water. What's the difference between what we've heard today? Well, Actually, is reclaimed water the same as gray water as in the reference standpoint?
Well, the terms are sometimes used interchangeably, but generally speaking, gray water refers to a lot of different waters that are not drinkable water, whereas reclaimed water in the industry is used more specifically to water that's been treated in a sewage treatment facility, at least secondary or tertiary treated, and then reused for industrial applications.
How many scenarios were evaluated in the 2015 study?
There were 15 separate scenarios.
What did the 2015 study demonstrate in regards to reclaimed water?
Well, the reclaimed water, stated earlier, was very difficult water to treat. It has very high ammonia, very high phosphate, and much higher dissolved solids, suspended solids to organic carbon than you would see perhaps in any of the freshwater supplies. The ammonia and the phosphate probably give us the greatest issues in a cooling tower application. These are generally, as many of you know, are termed to be nutrients. And these nutrients in a cooling tower create a great deal of problems with the biological quality. To remove them is expensive and difficult. And that's why I think there are many plants that use wastewater, reclaimed water, but all of those that I'm familiar with have some sort of tertiary treatment or denutrification to remove these constituents at the wastewater treatment plant, not at the power plant.
You mentioned fouling earlier, and we've heard discussion earlier about the ammonia. Could you please describe about, well, actually, let me back up. Do you recall the Council for Sierra Club asking Mr. Tibbs about the costs associated between gray water and well water?
Yes.
And how did the study evaluate the cost between those two water sources?
Well, we looked at all the treatment scenarios, and we developed what we call the net present value of each of the scenarios that we looked at. And this is basically a life cycle cost. And those are the numbers that we presented in the report. And it showed a significant difference between the cost of the freshwater supplies versus the reclaimed water source.
And significant being two times, 3 times?
A minimum of 3 times.
The cost.
That's correct.
Okay. So what was the ultimate recommendation of the 2015 water study?
Well, that study, we recommended that either the TVA use city water, potable water from MLGW, or if there was sufficient water supply available, if not, to use water directly from the Memphis Sand Aquifer.
Was there another study, you mentioned earlier, the addendum, correct? Was there a second study done within this entire water treatment study?
Yes, there was.
What did the second study look at?
Well, the second study, we were asked to look at the alluvium aquifer, and also there was some additional water analysis available to us. So we could check and validate the original study.
And what did the study demonstrate about the alluvium aquifer?
Well, the alluvium aquifer we found had some problematic constituents in it. Particularly in our case, it was iron and manganese. However, there were also higher levels of other constituents as well. Silica and hardness are a concern as well, because they also limit the cycles of concentration in a cooling tower.
And what was the ultimate recommendation for the second portion of the addendum, 2016 addendum, excuse me?
No, I think it confirmed that the best option from a both a cost standpoint and also from a reliability standpoint would be to use a freshwater supply, either water from the city or well water.
As a industrial water and water treatment specialist and expert with decades of experience, do you have anything else you would like to talk with the board about the water treatment study?
Only that the study, I think, and the addendum that we issued confirmed that most cost-effective system, most efficient, and the most reliable water source was water from the Memphis Sand Aquifer.
Thank you. I will pause and see if there's any questions from the board. Can I go ahead, Michelle?
Good afternoon. Did I understand that your business is doing analysis rather than producing systems? As a consultant?
I'm a consultant at this point, yes.
Okay. And have you testified as an expert witness for the Tennessee Valley Authority in the past?
No,
First time?
this is the first time,
Are you being compensated for your testimony?
yes.
Now, if I understood you correctly, you made a recommendation in 2015 that wastewater or gray water or recycled water not be used for the Allen plant.
Well, we determined that it was not a cost-effective source of water. And it had a lot of reliability issues associated with it as well.
And the reliability issues were what?
Well, primarily, it had to do with microbiological fouling in the cooling water system.
And that would be because of ammonia.
It was the nutrients, both ammonia and phosphate, contribute to microbiological fouling.
But neither of those issues would be relevant to the decision between using water from directly from Memphis Lake Gas and Water or from wells dug into the Memphis Sand Aquifer.
I'm not sure I understand your question, sir. Could you repeat it?
Well, did you, I understood your recommendation was that either MLGW water or water directly from wells into the aquifer should be used. Is that?
Yes, and that's the same water, basically. It's both sources are the Memphis Sand Aquifer. The water is very similar, except for some treatment that's done by the city.
Have you looked at studies or USGS studies in particular about seepage of water into the Memphis Sand Aquifer?
No, I have not.
And should that be an issue? If hypothetically there was water coming from the site of the well into seeping down into the water, would that adversely affect the quality of the water drawn?
Objection, Your Honor. This is outside the scope of direct and is also not his area of expertise. Do not testify as to the geological makeup of aquifers. He testified as a water source. So two different questions.
I'd like to ask the witness if he feels competent to address that question.
Well, I can answer the question. We will evaluate that if it occurred.
Okay. Did you do any evaluation of water as part of your study? The qualities of water?
I do.
Did you,
Seepage.
yes,
seepage was not a part of the study. We used the analysis that were provided to us from each of the sources, and those were the ones we evaluated. We didn't make any projections regarding what would happen if the water analysis changed. It would affect our analysis, for sure.
And I believe I understood you to say that the economic effect of water treatment would be a big factor in your recommendation. Did I understand that correctly?
Well, I think that's an engineering study is always based on the most cost-effective way to solve the problem, yes.
And in your view, could the gray water, recycled water be effectively used with proper treatment?
If you use very extensive treatment, similar to what you would do in tertiary treatment at a sewage treatment plant, you could duplicate that. You could get water treated to the point where you can use it.
When did you first become involved in this project?
Back in 2015.
Do you remember what month?
No, I don't.
And would it be safe to say, or would I be understanding your testimony correctly to say that you did not express a preference for which water source between Memphis Light Gas and Water or the well water was used?
Well, I think the exhibit will show that we recommended one or the other. If there was sufficient supply from the municipal water supply, it was a satisfactory supply. I will say that in our initial study, we included costs for the wells, the direct drilling into the aquifer. We included some costs for oxidation and filtration, similar to what the city was doing, because we only had some analyses to go by, and we had not done a test well at that time, and it wasn't until we got the later addendum showing the water from that particular point in the aquifer that we felt more comfortable saying we didn't require treatment of the well water.
And in other of your consulting, have you recommended use of gray water?
No, I don't think I've ever been in a position of recommending it. I have worked on projects where gray water was the only option available, and it was used.
And was the report that you provided that was introduced as an exhibit, I think it's 2 reports, was that the extent of your involvement in this project?
Yes.
I have no further